So good morning. Today we're going to take a look at gravity, which causes acceleration. So our learning target is recognize that gravity causes acceleration. Our background for today's talk is a picture of the International Space Station, and that is held into Earth's orbit by the force of gravity. It circles around Earth. It neither escapes into space nor does it fall to Earth. So recall from yesterday, we had talked about velocity, and yesterday's lesson was on acceleration. So velocity is a description of an object's motion. Velocity, remember, is a vector. It includes speed and direction. So velocity is how something is moving, speed and direction. Acceleration is a change in velocity. So this first oil drop diagram, shows constant velocity. The oil drops are evenly spaced. The speed and direction are not changing. Second one is positive acceleration. That is acceleration in the same direction as the velocity. You can see that the velocity is increasing. The drops are getting further apart. The third picture is negative acceleration. This is acceleration in the opposite direction of the velocity. So here we have something moving from right to left, but it is slowing down. Normally you think of that as deceleration, but in physics, it's acceleration in the opposite direction of the velocity. That is negative acceleration. So gravity causes acceleration. Why is it you can jump off your porch, but if you jumped off the roof of your house, you'd be more likely to get hurt? The reason is because you fall faster and faster the more time you're in the air. You accelerate. The longer you're falling, the more you accelerate, the higher your velocity gets. That means the harder you hit. If we could make an oil drop diagram of a falling object, it would show the acceleration. This picture shows the position of a dropped rock every second as it falls. So the instant it's dropped is t equals 0, and its velocity is 0. After a second, it is now going 9.8 meters per second. Every second, the velocity will have increased by 9.8 meters per second. After 2 seconds, it is going 19.6 meters per second. That's 2 times 9.8 meters per second. After 3 seconds, it's now going, I think it's 29.4. It's almost, 29.4 meters per second. It's 3 times 9.8 meters per second. After 4 seconds, it's now going 39.2 meters per second. Okay, that's 4 times 9.8 meters per second. Every second, its velocity increases by 9.8 meters per second. Using a strobe light, we can see that these water droplets are falling faster and faster the more time they have been in the air. The strobe light appears to stop the droplets. What it's actually doing is it's showing you different droplets on different flashes, but you can see that the farther down you go, the farther apart they are. That means the greater their velocity, just like our oil drop diagrams. Now we have to define something called free fall. We say an object in free fall is acted on only by the force of gravity. And over here on the right, we have what's called a force diagram. The object is depicted as a box or a blue rectangle, and the arrow is the vector of the force of gravity, because forces are always in a particular direction. They're vectors. So this box has only one arrow coming out of it. It has only one force acting on it, nothing else. That's the definition of free fall. Now, real objects are often have to deal with air resistance. But when we talk about free fall, we are not talking about air resistance. We're kind of pretending it doesn't exist to simplify the problem. So an object in free fall is acted on only by the force of gravity, nothing else, and especially not air resistance. We will talk about air resistance in the next lesson. Here on Earth, Every second, the velocity of a freely falling object increases by 9.8 meters per second. At the instant you drop it, its velocity is 0 meters per second. 1 second later, its velocity is 9.8 meters per second. After falling for 2 seconds, its velocity is 2 times 9.8, and I got that wrong. It should be 19.6 meters per second. After 3 seconds of fall, its velocity is 3 times 9.8, which is 29.4 meters per second. This is what happens if you don't use a calculator. Gravity speeds all freely falling objects on Earth up the same. So we say the acceleration caused by gravity is constant. If a number is constant, we can put it in a table and look it up anytime we need it. So the acceleration due to gravity is called g, and it is in your reference tables. So down here, I'll put a red box around it. Maybe the little there, that goes away. Red box around it. G is the acceleration due to gravity on Earth, 9.8 meters per second per second. Okay, acceleration due to gravity. G equals 9.8 meters per second per second. These are funny units. What do they mean? Gravity increases velocity by 9.8 meters per second every second. So the velocity increases 9.8 meters per second, or meters per second per second. We can also write them meters per second squared. So you have that extra per second in there because velocity is already meters per second, and every second the velocity increases. The acceleration due to gravity is a vector. It has a direction. The direction is downward toward the center of the Earth. Gravity accelerates everything downward. If an object starts out moving upward, gravity slows it to a stop, then accelerates it downward. When an upward moving object is slowing down, this is downward acceleration. It's acceleration in the opposite direction to the velocity. Eventually it stops, and then it starts accelerating down, and its velocity is in the same direction as the acceleration. So here are some different depictions of gravity. An object being dropped speeds up. The 1 second snapshots are farther apart. An object thrown straight up in the air. The velocity is upward. The acceleration is downward. Acceleration in the opposite direction of velocity means the velocity decreases, gets to 0, and then velocity downward begins to increase as it falls. Notice how symmetric the two sides are. The acceleration slowing it down as it rises is exactly the same as the acceleration speeding it up as it falls. This picture on the right is a projectile that is thrown with a little bit of forward motion, and gravity accelerates in the downward direction, does not affect its forward motion at all, keeps moving forward the same amount each second, but its upward velocity slows, stops, and then it accelerates downward. All right, so back to our learning target. Recognize that gravity causes acceleration. Anything that is freely falling is going to accelerate. Its velocity is going to become more and more in the down direction.